Okay, so as we were talking about in class, cost function is how much you spend. So C of X will be how much we spend on the in our business. R of X is our revenue. That's how much we bring in. And then profit is the amount you have after you pay your expenses. So your profit function will be the revenue function minus the cost function. Okay. Alina charges $35 to pressure clean a driveway, and her costs are $330 initially and a fee of $2 a day, or $2 per house for the water. So they want a linear cost function. So we're going to use C of X for cost. And this cost function, she has to pay $2 for every house for water, so 2X, plus she spent $330 on that power washer. Okay. Notice they said to use X for homes. So X is going to be how many homes she washed. Okay. Part B, revenue function. Revenue is the amount of money she brings in. She brings in $35 for every house, so 35X. And then our profit function in Part C, our profit function, P of X, will be, remember, however much she brings in, revenue, minus, oops, I should say just minus whatever her cost is. So minus C of X. Okay, so revenue was 35X minus her cost, so 2X plus 330. Now notice I'm minusing the entire 2X plus 330. That minus is going to have to distribute. So once I do that, I'll have 35X minus 2X, so I'm minusing the $2 for water, and then I'm minusing the $330 that she already spent on equipment. Combine like terms to simplify. 35X minus 2X is 33X minus 330. All right, so her profit, remember she brings in $35 per house, but she spent $2 a house. So 35 minus 2 rather is 33, but she's also spent $330 on that other equipment. So her real profit, how much she gets to make and keep after all of her work, will be 33 times how many houses she does minus the 330 she already spent. Okay. Part D, how much will she make if she washes 15 homes? Now, how much profit? So we're going to put into the P of X function, and she washes 15. So we're putting in 15 for X. So we're going to use our P of X function. Every time there's an X, we're going to put 15. So 33 times 15 minus 330. Work that out. Type that in your calculator, and it's going to come out to 165. That means if she washes 15 homes, she will have $165 profit. So after she pays all her expenses, she'll end up with $165 left over as profit. Part E, how many homes must she wash to make 330? So we're still going to use the profit function, but 330 is not X. This time we're setting our profit function, the 33X minus 330, equal to 330. We want her profit, this part, to equal 330. And we solve this equation for X, so add 330 to both sides. 660 equals 33X, and divide by 33, and we're going to get 20. That means if she washes 20 houses, she will have $330 profit. So she'll be able to pay all her expenses and still have $330 left over. Last one here talks about break even. Okay, break even means you don't make any profit, but you also didn't lose money. So if you look at this little graph here, this is our cost function. So as she washes more and more houses, cost goes higher and higher. Here's our revenue. As she washes more and more houses, her revenue goes higher. So break even would be this point. So if she only washes a few houses, like 3 or 4 houses, her cost will be higher than her revenue. So that means she loses money. If she washes enough houses, her revenue will be higher than her cost, so she has profit. Break even is this spot right here. That's the spot where her cost and her revenue are equal. In other words, she makes enough money to cover her expenses, but she doesn't make enough money to have a profit. Okay, so break even means that your profit equals 0. So in other words, we're going to take our 33x minus 330, our profit function, and say it's equal to 0. So when does 0 equal 33x minus 330? And we're going to solve that equation for x. So plus 330. 330 equals 33x. Divide both sides by 33, and we're going to get 10. So that means she will break even if she washes 10 houses. That means if she washes 10 houses, she will make enough money to cover her expenses, but she will not have any extra left over for profit. She will break even. Okay. Next one, this is a similar question I think on your homework. A salesperson makes a base salary of $600 a week plus 15% commission on sales. So part A here, write a linear function to model the salesperson's weekly salary S of X for X dollars in sales. So they're saying use S of X. We don't know why they picked S. To me, I might like to use, well, I guess we could say S for salary. S for salary. Salary depending on X dollars in sales. So if you sell X dollars, how much are you going to make? Well, they tell us that the person gets $600 a week no matter what. So 600 plus their commission. Commission means if you sell something, you get a percentage of that money to keep as your earnings. Okay, so 15% as a decimal is 0.15. So if we multiply 0.15 times however much you sell, that will be your commission. So the person gets $600 plus 15% of whatever they sell. It would probably be better to write it as 0.15x plus 600. And the reason that's a little bit better is it fits that y equals mx plus b format that we can tell is linear. So either way is okay. I think the circle version is a little bit better. And then B, they want S of 7,000. So remember, every time we put a number in parentheses next to that variable, we're saying plug in that number for X. So 0.15 times 7,000, we're plugging in 7,000 for X, adding it to 600, and we're going to type that in our calculator. 0.15 times 7,000 plus 600, and we get 1,650. Okay, and then notice it says interpret the meaning and context of the problem. That means, what does this represent? Well, 7,000 was how much we plugged in. That was how much the person sold. So if you sell $7,000 worth of merchandise, you will make your salary, how much money you make, your salary will be $1,650. Okay. All right, number 9 here. Another one of those profit ones, profit, revenue, cost equations, but there's one little twist, and there is a homework question like this, so I thought that would maybe help. A small business makes cookies and sells them at the farmer's market. The fixed monthly cost for use of a health department approved kitchen and rental space at the farmer's market is $700. Okay, so that fixed cost, that $700, that means you get to rent a space. You get a kitchen to work in, it's been approved as being clean, and you're able to use that, and your storefront there. So they're going to pay that $700 up front, sort of like rent or initial expenses. The cost of labor, taxes, and ingredients for the cookies amounts to 27 cents per cookie. So they figured out that every cookie that they make costs them $27 for the ingredients, to pay whoever the worker is to make the cookies. So it costs them 27 cents for every cookie they make, plus another $700 for the space. Okay. Notice that they sell the cookies for $4 per dozen. More on this dozen thing in a minute. Okay. All right. So our cost function, our C of X, our cost function, we spend 27 cents on every cookie and $700 for the kitchen. Now, I would point out that if you, the price per dozen, they're selling them in dozens. So in other words, people can't come up to us and buy one cookie. They've got to buy a whole dozen. People have to buy a whole dozen cookies, and it costs them $4. Well, later, so that's going to be my revenue function. My revenue is going to be 4x, $4 times however many dozens we sell. But I can't use dozens for X in revenue and single cookies for X in cost. So what I'm going to have to figure out is I'm going to have to make this cost function also be in terms of dozens. So if it's 27 cents per cookie and there's 12 cookies in a dozen, 0.27 times 12 is $3.24. So that means it costs me $3.24 for every dozen cookies I make. Yes, that's 27 cents per cookie, but that means it will be $3.24 for a dozen cookies. And then I paid my $700 for the rental fee. Okay? My revenue, I'm selling them at $4 per dozen. So I bring in 4X. Profit function, remember profit is always revenue minus cost. So our revenue was 4X. Our cost was 324X plus 700. Notice I've got to subtract all of that. So I distribute that negative. So 4X minus 324X minus 700. Combine the like terms. 4 minus 324 is 0.76. 4 minus 3.24, 76, yep. So 0.76x minus 700. Our profit will be 76 cents a cookie, but then we'll have to subtract off the $700 for renting the kitchen. So that's our profit function right there. They ask how much the business will make if they sell 25 dozen cookies. Remember, X was how many dozen cookies there are. So if we sell 25 dozen, we're finding P of 25. So 0.76 times 25 minus 700. Is negative 681. Okay, now what does that mean, negative 681? Well, you want your profit to be a positive number because that means you made money. So if profit is a negative number, then that means we did not make money. We spent more than we made. So remember, 76 cents times 25 dozen, that means you basically made $19. 76 cents for each dozen times 25 dozen is $19, but you also spent that $700. So we are in the hole, if you will, $681. So that means if you sell 25 dozen cookies, you will lose $681. So that would not be good. That means we need to sell more than 25 dozen if we're going to make money, okay? And then they want to know the break-even point. Remember, break-even is where you don't make money, but you don't lose any. So your profit is 0. So we're going to say, okay, well, when does 0 equal our 0.76x minus 700? It's taking that profit equation and setting it to 0. Well, I'll add 700. So 700 is 0.76x. Divide by 0.76. And we get 921.052. So in other words, I would need to sell 921.052 dozen cookies. Probably makes sense to round it here to the nearest whole number. So the nearest whole number would be 921. So if we sell 921 dozen cookies, not just cookies, but dozen cookies, 921 sets of 12. If you sell 921 dozen cookies, you will break even. That means if you sell less than 921 dozen, you will lose money. If you sell more than 921 dozen, you will make profit. If you sell exactly 921 dozen, you will break even. Okay? And then our last one here, this is also from your homework. Okay? It says Caroline adopted a puppy named Dodger from an animal shelter in Chicago. She recorded Dodger's weight during the first 2 months. The data in the graph shows Dodger's weight in pounds, X days after adoption. Okay, so notice here, X days. That means on the X-axis we're putting the days. So the days she adopted him, 0 days had passed. So that was this initial point right here. This 0, maybe around 11 or whatever that number is. is his weight on the day she adopted him. No days had passed. Let's see another one here. Well, they tell us that this point is at 14.3. That means 12 days after she adopted him, his weight is 14.3. So notice that it shows the weight in pounds. So our y-axis has the weight, and the x-axis has the number of days. Okay. They've given us a couple of points, 12 and 14.3, and then 40.22 is another point. So since we have 2 points, that's x1, y1, and x2, y2. So A says use those points to write the linear equation model. Okay, so remember, we need the slope first. So y2 minus y1 divided by x2 minus x1. So let's see, that's 7.7 over 28. And I can't have decimals in my fractions, so 7.7 divided by 28, there's the decimal. But if I hit math, enter, enter, it'll reduce it for me to 11 over 40. Okay, so that's our slope. Okay, and then we can use our y minus y1 equals m times x minus x1, and we can plug in and find our equation. So y minus y1 was 14.3, equals m, which we figured out was 11 over 40, times x minus 12. Okay, so y minus 14.3 equals 11 over 40x, and then I've got to multiply my 11 over 40 times 12. Of course, it's a decimal. If I turn it into a fraction, I get 33 over 10. And then I'm going to add my 14.3 to both sides. And y equals 11 over 40x. And then I've got my 33 over 10, and I've got to add 14.3. So that comes out to be 17.6. Yes, did I mess that up? Over 40. Okay, so plus 17.6. Okay. So that's our equation. Use these points to write a linear model. I feel like I messed up. Hang on. I'm checking my scratch work because I used the other point there. 22. Minus 12, 28, 7.7 over 28, 11 over 40. So y minus 14.3 equals 11 onto x minus 12, 11 over 40 times negative 12. Oh, negative 3.3, that's what happened. Yep, positive times negative is negative. So negative 3.3 plus 14.3 is 11. There we go. There we go. That's what was supposed to happen. Sorry about that. Okay, so negative 11 over 40 times negative 12 is negative 33/10, and then we add 14.3, we get negative 11. I'm sorry, we get positive 11. Okay, so our equation for part A, our equation is y equals 11 over 40x plus 11. Part B says interpret the meaning of the slope. So 11 over 40 is our slope. What does that mean in regards to our context, in regards to our problem? Well, remember, it's rise over run. So 11 is the rise and 40 is the run. Well, what's rising? What's on our y-axis? Weight. So that means the puppy's weight must go up by 11 pounds. I know it's pounds because that's the unit over here. Every time 40 days go by. So puppy's weight increases by 11 pounds every 40 days. So remember, rise over run. Rise was 11, that was weight, so weight goes up by 11. Run was 40, run is the number of days, so every 40 days. Okay. Part C, interpret the y-intercept. The y-intercept is the 11. And that would mean initially 0 days had gone by, because that's representing the point 011 right here. 0 days have gone by, and the puppy must have weighed 11 pounds. Puppy weighed 11 pounds when adopted. Okay. Part D, if this trend continues during Dodger's growth period, how long will it take Dodger to reach 90% of his expected full-grown weight of 70 pounds? In other words, when Dodger is full-grown dog, he's going to weigh 70 pounds. When will he get to 90% of that? Well, first I need to know what 90% of 70 pounds is. So 0.9 times 70 is 63. So, in other words, when will he get to 63 pounds? That's what they want to know. They say, when will he get 90% grown? Well, 90% of his full-grown 70 pounds is 63. So they want to know when he's going to get to 63 pounds. That's not the days of adoption. X is our days of adoption. Y is the weight. Okay? So we want to know when 63 equals the 11 over 40x plus 11. That's the equation I'm solving. Okay? So we'll minus 11. 63 minus 11 is 52. 52 equals 11 over 40x. I'm going to multiply by 40 over 11 to cancel and get x alone. If I multiply the right by 40 over 11, I better multiply the left by 40 over 11. So 40 over 11 times 52 is 189.09. You can round that off there. So they said round to the nearest day, so that would be the nearest whole number. So it's going to take about 189 days. We'll take 189 days. So in other words, if I went out here to 189 days, which is way out here, 50, 60, 70, all the way out to 189 days, my graph would be up there at 63 pounds. Okay? And then the last one here, Part E, is the model from Part A reasonable long term? In other words, is this equation we got from Part A reasonable? And I'm going to say no. And the reason I'm saying that is because if we keep this going forever, long term means, keep on going forever and ever. Eventually, this dog is going to stop growing, okay? Whether it's animals, people, whatever, we reach a full-grown status. And they already mentioned his full-grown status was 70 pounds. If this equation continued forever, that meant 6 months, a year, 10 years from now, this puppy would weigh, 500 pounds. And I'm scared of a 500-pound dog. So we know that it's not going to go forever. So I'm going to say no. It implies that dogs grow forever, but we know eventually the dog will be full grown and he won't grow anymore. Okay? All right, hopefully that video helps a little bit. Thanks.